Frosch. I'm very happy to be here, sponsored here by No Fluff. So a little bit about me, if you didn't read the bio, so I've been doing this for Java for about 20 years come May, and Groovy Grails for the last 7 years. That's primarily what I code in nowadays is in Groovy. And occasionally Android since about version 1.5. At Spring 1, I presented on building a microservice federation with Grails, and then building beautiful Grails apps with Bootstrap at the Dallas Jug. And I gave this talk to the Madison and Milwaukee jugs in Wisconsin back in October. I did run St. Louis, one of the 2 jugs in St. Louis, the Gateway Jug. Founded it and ran it for 13 years. Then I took an assignment in Dallas and was a co-lead on the Groovy Grails user group there. So I do really believe in user groups, so if you have not been involved with the user group, every time Paul asks for volunteers or asks to do something, you really ought to step up. This is really a good chance for you to get involved in the community and give a little bit back. Twitter is at Frosch, and on LinkedIn, please feel free to connect with me. ArchConf was mentioned, so this is coming up. The cool thing is, it's ArchConf West is here in San Diego in April. I went to the ArchConf East in Fort Lauderdale in December, and it was absolutely fantastic. The worst part about it was I constantly had conflicts of topics that I wanted to see. So I went down one track, and there's this 3 other topics that I just was dying to see, but they were, I mean, you can only do so many things. I also did the workshops there all day with Mark Richards and Neil Ford, a fantastic opportunity. So I'm not sure what the workshops are, but it's here in town, so really, if you're interested in architectural things, this is really a great conference for you. In the general JVM development area, the No Fluff comes in June. I'm not sure if I'm slated to present here at this point, or they're planning on that, but the April schedule was filled, and so I've got three locations in April, and I said I was going to be available pretty much for any show. I might be at UberConf as well, so if you go to UberConf in Colorado, please come out and join us for one of the No Fluff is a fantastic development experience as well. A lot of the topics, what I'm talking about here, you see presented in Java 8, Android topics, Groovy Grails topics. It's just really a great conference, and it's usually over the weekend. So come in Monday, all refreshed. Now, before we begin, I need to say that Java 8 is not Java 1.8. We've gotten rid of the 1 point anythings, so it was always confusing. We called it Java 5, but the developers worked with 1.5. Java 6, and the developers worked with 1.6. Well, we don't do that anymore. It's all just Java 8, and then it'll be Java 9. The JDK is for Java 9, Java 8, and Java 8 has many useful but boring enhancements. I'm going to just talk about the game changers. Ken Cousin does a talk on Java 8, and I let him talk about the boring topics. But these are really game changers. If you know Venkat Subramaniam, been talking about functional programming with Java for a while. It's really inspired by his book. And Ken actually covers a lot of the really cool stuff. It's such a big change from from 7 to 8. There's just no way in a presentation like this that you could cover all of the interesting features that have come into 8. The ones I'm going to talk about are not just interesting features, but they'll change the way you actually code. So, what are some of the game changers? Interface enhancements. They are so simple, when I show them to you, you're going to say, why didn't we have that all along? It's just so simple, so elegant. Well, we needed to evolve to get here. Lambda Expressions, Venkat calls these the gateway drug to functional programming. They really are. They make your code more fluent, much easier to read with Lambda Expressions than it would be, say, with anonymous inner classes. Anybody who's been down that path. Streams free the developers to think about what to do. What is it that you're wanting the computer to do? as opposed to how the computer should do it. And we'll see examples on that. Now, the first thing is interfaces. Prior to Java 8, we had interfaces that had abstract methods, no state, only static final constants. They could inherit from multiple interfaces. And classes can implement multiple interfaces. Gave us kind of a feeling of multiple inheritance without, the problems with multiple inheritance. What happens with Java 8 and going forward? Well, we have abstract methods, no state, only static final constants. Interfaces can inherit from multiple interfaces, and classes can implement multiple interfaces. Well, gee, that's not a big win. Then we add default methods. So now you can implement a method on the interface, and it is the default implementation for that method. You can also put static methods with fully implemented methods on interfaces. And you can declare certain interfaces to be functional interfaces, and we'll talk about what the definition of a functional interface is. So, how many of you have been programming in Java for more than 3 years? Yeah, the whole group. So I'm not going to show you like the classic interface stuff. So if you're interested, after the talk, we can go through that. But it's pretty limited. Now, here's a question I have for you, since you guys have been doing this for a while. What if Oracle had done this in Java 8? They said, hey, this compare to method on the comparable interface is really useful. But it would be nice if we could put a method on there called is comparatively equal, which basically just evaluates the compare to if it's equal to 0. Right? So if it is, then we could say, well, it's comparatively equal. It may not be equal in the sense of the equals in hash code, kind of equality that we get with the equals method, but we could say, comparatively speaking, it's equal. What would happen if Oracle had done this on Java 8? This. Chaos, complete chaos, madness, anger. Developers around the world would be grabbing their pitchforks and torches and marching up on Oracle. What are you doing, man? And finally, total confusion. What worked yesterday doesn't work today. But we didn't make any code changes. Nothing at all. We just, we said we were going to upgrade to 8 and it was supposed to be backward compatible and it's all broken. And why is that? Prior to Java 8, interface methods were effectively frozen. Any changes you made to an interface would effectively break what is published API. You add a new abstract method on an interface, everybody who implemented that interface is now broken and would have to implement the method for the interface. This meant Java could not evolve the APIs. So interfaces like the runnable interface that we use with multi-threading has had public void run since Java 1.0. It has not been able to be changed in almost 20 years. Why? Because if you change it, you would break everybody's Java environment plan. So this was a problem. If we didn't fix it, the Java might be doomed because developers have expectations about how collections should behave now and how interfaces should grow to be more robust. And if we were frozen with interfaces, we wouldn't be able to do that. So what we could do, and this is for illustration only, again, Java 8 doesn't really do this, is we could define the is comparatively equals method on here, and all we have to do is make it the default method. So this is an interface, but now I've added a new method to the interface. And I've provided a concrete implementation. Since there's a concrete implementation, and I publish this interface, does it break anybody's code? No, because there's a concrete implementation of the is comparatively equal method. So now the Java API designers could go forward and enhance the APIs, which, by the way, they did on many of the common interfaces that we use in Java all the time. So let's talk about what this looks like. So since I'm not going to actually change the comparable interface itself, I'm just going to make a new interface called custom comparable of some type. And I'm going to extend comparable. And I'm going to add this method body on there. Basically, I'm just saying, hey, if you're comparatively equal, then return true, and if you're not comparatively equal, return false. So I have a dog 2, actually, let's see. So I have dog 2, and dog 2, dog 1, which we didn't show was in the class interface. Dog 2 implements custom comparable, which means I'm going to get the compare to, but I'm also going to get the is comparatively equal. And I have 2 string, and I have to get compare to. So what we do on the compare to, we say, well, compare the owner's last name first, and if they're equal, if they're the same, then compare the dog's name. The equals method, however, not only compares the owner last name and the dog's name, but the last vaccination date. So it's a stricter kind of equality, isn't it? Comparatively equal just says, owner last name and dog's last name is enough. So what do? We set up some dogs, Fido Smith. There's a Fido Smith and a Fido Smith 2. There's a Fluffy Jones and a Fido Jones. And then I have an array of all of these. And what I'm going to do is print out whether they're equal or not. So first of all, notice these aren't sorted initially, and so I can get them in any order, but I can do a sort on them. So first I unsorted, we see that we have Smiths and Jones are all mixed up, and the first names. Then when we sort them, we see that the 2 Jones come together, and then Fido and Fluffy are sorted appropriately. Then there's Fido Smith and Fido Smith, because there's, Smith's common name, and Fido turns out to be a common name. So, but the last vaccination dates we notice are different. So when I do comparatively equal, I can say, is Fido Jones and Fido Smith equal? Well, of course they're not. Are they comparatively equal? They're not. How about Fido Smith and Fido Smith number 2? Are they equal? They are not, because they have different vaccination dates. So from the equals method, they're not equal. But are Fido Smith and Fido Smith number 2 comparatively equal? And since comparatively equal in the way I implement it is a weaker equality than the equals, we can say that they're true. So what this shows is that we can create a brand new interface and add additional default method to it, and then or add it to our existing interfaces, and no code gets broken. The problem is, how many of you have programmed in C++ with multiple inheritance? Like, how bad was your life when you had multiple inheritance with C++? It was horrible. You'd be tracing down bugs that were really abstract, and the reason is because when you have multiple concrete inheritance, you never know really what the implementation is that you're going to be picking up. This is called the diamond problem. So class B extends from B and C concrete classes, and they extend from A. And so then when you have a method that is on A, B, and C, which implementation are you going to be invoking from D? It's really quite a problem. So we have to solve that. The default method thing has to solve it. So the method resolution works like this. First of all, subtypes carry default methods from supertypes. That's exactly what we would expect. If I have a default method on a parent interface, then a super interface, and then I have a sub interface below that inherits from that. And if the sub interface adds the same implementation, adds an implementation for the same method, then the subtype wins. And that would otherwise our polymorphism would be completely broken. So this works. Subtypes default method will always override the supertypes, as I just said. A class implementation of a method that's defined either as a default, any default interface implementation anywhere up the hierarchy, the class implementation always wins. Okay? And then if there's a conflict between 2 default methods, or a default method and an abstract method on a class or an interface, it requires the class to implement the method. Now here's one key thing, right? On an abstract class, if you have a class and you implement an interface, but you don't really know what you want to implement, what kind of behavior you want to implement the interface's method, the old classic abstract method, what would you do to the class? You'd have to make the class abstract. Because if you don't implement the method, you have to be abstract. And so the workaround was just, hey, I will make my class abstract and I won't worry about it. Turns out with default methods, you can't do that. So if interface A and interface B both have a foo method, and my class implements it, A and B, I have to put a method on my class. I can't just declare my class as abstract and punt to my subclass. So method resolution works like this. I have a classic interface, readable. Turns out this is a functional interface, and we'll talk about that here in a second. But readable has a single abstract method. There's an interface called English that extends readable, and it provides a default implementation for read, and it just prints out hello. French prints out the French, German prints out the German. American English extends the English interface, and it just prints out hi. And I'm exposing a method here called Greek formal English, where I kind of reach around and go to my parent, and I go to the English interface, and then call its Greek method. So how do we do this? First of all, if I put the Greek method on my class, as I've done here, then I'm fine. Because there's no ambiguity. Reader implements American English, French, and German. They all have Greek methods. And so remember, I said if there's a conflict, the class has to implement the method to sort of disambiguate it. If I commented that out, we would get a compiler error that would say the methods are ambiguous. Then I make a new greeter, one of these. I call Greek, I greet in French, I greet in German. Then I call the Greek and American English, no problem. Now I want to greet in English. When I do the greet in English, I actually call that other method called Greek formal English, and that allows me to reach around and get that upper interface called English. But this is how, if you don't do that, because I didn't implement English up there, you can't say like American English.super.super.Greek because you can't put multiple supers there. So it basically is hidden, the one that I didn't implement from the
Quick question.
And then I get the greetings out. Question?
Yeah, so you say the interfaces can inherit from
Right.
another interface, and each one can have a default method. Can a sub interface call the supers interface default method within its default method to concatenate?
Actually, we do that right here. So this interface reaches around to call. So I could have implemented my Greek to be English.super.Greek, for instance. So yes, I can call up the stack. But if I get two of them that are hiding, then I have to work, I have to put in some machinations to make that work. So I mentioned functional interfaces. They're actually amazingly simple in concept. You have to have a single abstract method, a SAM. Single abstract method. That makes a functional interface. You may implement static methods, 0, 1, or more. You may implement default methods, 0, 1, or more. You may tag the functional interface, the interface that you have with a single abstract method, with that functional interface. What does that buy you? Nothing in performance. It buys you a nice big compiler error if you put more than one abstract method on your class. So you start off with one abstract method, and you say, oh, that's going to be our, functional interface, and we have one abstract method, no problem. Then later on, someone says, oh, it'd be nice if we had another abstract method on here. If you don't have the tag for that functional interface, the compiler's not going to tell you you have now broken the contract for a functional interface, and so it's going to be a problem. You might get compiler errors in other places, but which will be harder to sort of figure out what's going on. if you put this, it'll just tell you, hey, you no longer meet the requirement. So some examples you already know. We've used them, one comparable, oneable, other many in Java. Some new ones in Java 8, consumer, function, predicate, supplier. And then there's a function called java.util.function that has a lot of these, all of these functional interfaces that Java declares. And you can create, obviously, your own functional interfaces. So what do they give us? If a method takes a functional interface as a parameter, we can pass the following as an argument. An anonymous init class, just like we did in the old days. And if you work with Swing, you've probably seen this. If you do Android programming, you're probably sick of these by now because you use them all the time. In Lambda Expressions, the new functional element that comes with us with Java 8, we can do that instead of the functional interface. This is way cooler than it seems right here on this slide bullet point. We'll see some examples. But what we're saying is if I put a lambda there, the compiler will figure out what the functional interface should be. And under the covers, it basically is working with it as though it's a functional interface. So it's very cool. You can also pass in a method or constructor reference, and I've got some slides and notes. So here's the predicate interface. Notice it's tagged with that functional interface. It has a single abstract method, text, and it returns a Boolean. And you pass in the type that the predicate is declared with the generic. So here's an idea. We have, I have some method called pickSum. I'm going to send you in a list of integers, and based on some strategy, some picking strategy, you're going to then pick whether the value is appropriate, right? Like, does it meet the requirements of the picking strategy? So I make an array list, and then I loop through all of the candidates, and I call the test method passing in the candidate, and if that is true, out of that test method, then I will add that candidate to my set of results. And so this is one way we can do it. So what does it look like with the anonymous inner class? Here's my list of integers. I'm going to call pickSum, and I'm going to pass in that list, and I'm going to pass in a new predicate anonymous inner class implementation of a predicate. And what I'm picking here are whether the value is an even value, right? And so for each value in the test, for each value in the list, I'm going to run through and evaluate it using this looping. Okay, so that's anonymous inner class, and it sucks about as much as all anonymous inner classes do. Here it is with a lambda expression. This says, pass in the values, declare a variable of type, declare a variable called value, and use that variable value to evaluate it if it's divisible by 2, and if it comes out to be 0 for the values, then we'll say it's true. And that result, because that Boolean check allows us to do the pick. Now notice, I did declare that it's of type integer. And that's because the list of values that I'm working with are all integers. And so the compiler looks at, and so the Java 8 magic, a lot of the Java 8 magic comes from the use of generics. By declaring the list as being a list of integers, the compiler can then infer what the type of the value is here. We don't have to declare it. We can declare it, but we don't have to. So the general form of Lambda expressions is this. I have some arguments, type, multiple arguments. I enclose those in a parenthesis. I have a dash, a greater than sign, and then curly brace and some statements, close curly brace. That's really pretty wordy. Now, if I have no arguments, this part I hate. I wish they had fixed this and not required this. Being a Groovy programmer with Clojures, I don't have to do this. It annoys me when I do it in Java. I do. If I have no args, I have to have empty set of parameters. right, for the variable, and then my statement body. If I have one argument, I can put it in parens, and then have the statements. But if I can infer the type, like we just did, I can leave the type off and put it in parens. But if it's only one statement, I don't even need to use the curly braces for the statement. And if the argument if there's only one argument, I don't have to use the parens. Which is why here, I didn't need the parens, I didn't need the curly braces, and it really reads cleanly. Very fluent looking expression. Now, I said they modified a lot of the interfaces. The iterable interface, which has been around for some time, they added the default method called for each on iterable. And basically, it loops through, it iterates through with the iterable, and then it takes a consumer interface as an action, and then it calls the accept method. The consumer is basically just saying, hey, if you want me to do something with some data, just define it in the consumer interface, and then when I call accept, I'll invoke that behavior. So that's what consumer looks like. So here we have a list for each. There's the use of for each. And this is using standard Lambda. Value, hyphen, greater than, and then I just wanted to do something with that value, in this case, print it out. But I could also say list.forEach system.out, ::println. Now this is a method reference, another new feature of Java 8. So if I have a method that's declared like this, map, take some function, instead of using the lambda, I can just invoke the method that I want to use on the element. And so we're going to see these method references used in some other examples here, but there are really three kinds of them. You can have a static method, and so a class, : some static method. An object, : some instance method. Now the ones that we just saw with the uppercase, we can have a class, : some instance method. Now the only reason this works is if the type can be completely inferred, and so when I have some arbitrary object of a particular type, then I can use this syntax, and that's what we see here. So I can use string : two uppercase. Two uppercase is an instance method, but since the things that I'm operating on are strings, all strings have a two uppercase, so I can just invoke that method. And finally, and this one is a little strange, we have a reference to a constructor. So instead of directly newing up a constructor, I can use the class name : new. So the new here is not an operator, but it's a special method that's available on the class. So using method references, we see I have my list, I have the for each, and then I can do the lambdas, or I can go right to the instance method on the output string they call println. This println will get, for each value in the list, the iterable will iterate across. This gets compiled, the system out, : println, that gets evaluated as a consumer interface. And what's on the consumer interface? Accept method. So the iterable loops through these in the for each and calls the accept method, and it passes that behavior in to be executed in that accept. And that's basically, so in other words, it's just going to print the values out. So here's some a little more robust code for the method reference. I have some strings. I can use lambda, as I said, names.forEach. Name, right? What's the type? It's a string. Why? Because it's a list of strings I'm operating on. And then I just say hyphen greater than, and then execute something. That gets, the compiler treats that as a consumer interface, and so the accept method gets called with that behavior that's in the statements, in that Lambda expression. Now, another way to do it is to take two uppercase. So that two uppercase. But then I can take that transform values and then just call system.out print, and that gets me that gets treated as a consumer interface and works just being. And then we get this. Starts out as lowercase, a mixed case, and using Lambda, we didn't do any transformation. Then we use the transformation to uppercase, and we get the same set of values. The constructor reference is a little more abstract. So I'm using that foo : new to create the object. But I'm calling an actual factory method here. And so I loop through 10 times, I call the create method, and I pass in foo : new. Foo : new sees that the argument to this create is a supplier. So sorry, there's a typo there. It should be : new returns a supplier of type for types foo. And then this outputs the instance count. So as I look through here, I will see the counts of the instances go up, all because I got a supplier from foo : new. This works because the only constructor I have is a default no-arg constructor. The supplier interface, the functional interface for supplier, it has a single method called get with no arguments. So this works perfectly fine. Foo : new returns the supplier. I just call the get on the supplier to get the actual instance that was created. Okay? Now on the second demo, I now have a default constructor and I now have a local time. The date time library in Java 8 is very much like Joda time. So if you've worked with that, a lot of the names are the same or will be very familiar. Local time is just the time part of what we would normally call in a Java util date, where we had the date and the time. Local time is just the time part. There's also a local date, which is just the date part. And there are lots of really great utility methods on these. One of them is a now method. So I can call now, and it basically gets the system time in local time. So what happens here? I still have to create, but notice now instead of a supplier, right? That's what we used before. We had supplier. Now I'm saying I want this to be a functional interface, and it's hard to say that 3 times. The functional interface is defined with 2 types: the input type and the output type. So I'm saying here, my input type is going to be of type local time, and my output type is going to be a foo, and it has one method called apply. So when I pass in a type that is local time, I will get back the foo. So now foo : new doesn't return a supplier, it returns a function. Why does the compiler know to return a function? Because I've declared that that's how I'm going to be using it, as a function. Wow, this compiler inference, if you've been doing Groovy stuff, this is like, okay, yeah, we can figure it all out, right, at runtime or whatever. This is all happening at the compile time still, and the compiler is figuring out, hey, this guy's going to use what comes out of foo : new needs to be a functional interface. And so now, let's say that I had 3 constructors, and one constructor took a string, one took a local time, one took a long. Then I could still handle these with this function type. I would have 3 separate creates perhaps and do that, or I might make this more generic. So that's how we get that out. Again, we get the instances. Now this one is more complex. What if we have like some constructors that have 4 arguments or 3 arguments or 2 arguments, or some that have no args, and so we have all these different overloaded variations? Well, you probably need to think about your strategy about having constructors like that, because it's a little confusing. But if you do that, by the way, here's our times. It looks like I just have time information here, and then the instance number. So if I had a constructor Java's function interface doesn't work anymore because that only takes one argument. So without like, you know, tricking it up to be the argument is a list or something more strange, what I can do here is simply declare my own functional interface. This is the food factory. It takes as arguments string and local time, and it pops back out a food. So now food : new is getting assigned to a food factory that takes a string and local time. So the compiler will ensure that food : new produces that functional interface. Then I pass that functional interface, or I just use that functional interface. I call the create method of it. Oh, actually, might be a typo here. So I can just call, my method is, I can just call it create on that and get that out. I'll have to check on the GitHub. Paul, I'll send you a GitHub link. So all the code is live and you can download it. I think it's just a slide artifact here. So you see, with method references and constructor references, I can now pull myself out from the low-level details about using the methods, and I can now write them in a more fluent way. This, the constructor one is always a little contrived because you may or may not have factories that figure out how to do it, but just know that it's available for you. And then we get, we output the message, and then we get the time, and then the instance. Okay, so all of that lays the groundwork for working with streams. All right, how are we doing on your break time?
You're 10 minutes before 8 if this is a good spot.
We're going to do that, so we'll break. You guys take a little break, so we'll do that, and then we'll go into streams.
So let's regroup at 8 o'clock and
10 minutes.
The restrooms are in the back.